we have a session on creating a talent ecosystem for EV industry by Krishna Bandaru, Executive Leadership SKILL-LYNC. SKILL-LYNC offers industry-relevant advanced engineering courses for engineering students by partnering with industry experts. Now I welcome Mr. Bandaru. Please take it ahead. Over to you.
Good day, everyone. This is Krishna Bandaru from SKILL-LYNC. First of all, thanks to ET for having SKILL-LYNC speak on this very important topic about creating a talent ecosystem for powering EV revolution in India. Before I get into the topic, just a brief introduction about SKILL-LYNC. SKILL-LYNC is a Y Combinator firm. We're funded by Iron Pillar. We've basically built an engineering education platform in order to bridge the gap between academia and industry. That's also helping the industry to recruit trained and skilled engineers, and a lot of corporates use our integrated learning platform for upskilling their own employees as well. Now, coming to the topic at hand, creating a talent ecosystem for powering EV revolution in India. What are the industry megatrends? I think this is common knowledge now. All of us are aware that EV penetration is bound to increase in India. Most of these vehicles are going to be connected, and some of them are going to be autonomous as well in the near future. What do we need to do in order to capitalize on these megatrends? We at SKILL-LYNC believe that India needs a massive engineering talent pool to capitalize on these megatrends. Who requires this talent? There are three segments. Number one are the Indian OEMs and the tier one suppliers, or the supplier ecosystem, which is there in the EV value chain, which requires this workforce in order to design EV vehicles for India. Number two, the number of global OEMs and suppliers who have their engineering and innovation centers in India. They're banking on India for a significant amount of engineering talent. They require this engineering talent pool. Number three, the number of engineering service providers who are already providing engineering services to global OEMs, especially in the EV, autonomous, and the connected space. They require this talent pool. This talent pool is required across multiple layers, whether it is at a component level, at a system of systems at the electric vehicle level, or to make it even connected and autonomous. Before diving deep into each of these layers, let's try to understand what are the fundamental skills that are required for our engineers. While these might seem very, very fundamental, but they are in short supply. So it's very important that we impart this knowledge, whether it is about understanding of the physical system, mathematical understanding of the simulated system, and knowledge of the simulation tools and methods and how to interpret these results. Given that simulation plays a critical role in during the design and engineering phase of these vehicles, it's very, very important to have these three basic building blocks before they dive deep. This is almost like a horizontal skill sets which cuts across whether you're designing components, whether you're designing electric vehicles or autonomous vehicles. Now, coming to the skills for engineering vehicle components, whether it is for a battery pack, whether it is for a battery management system, for an inverter, electric machine, or for the charging system. All of these require, or most of these require, interdisciplinary skills. They require mechanical engineering skills such as mechanical and thermal design, especially for battery pack. It requires a lot of electrical design and functional safety skills. It also requires a lot of software skills, especially in the embedded hardware and software design, because there's a significant amount of embedded systems in each of these components as well. At the bottom of the screen, we've listed down some of the software tools. The reason why these software tools are very important is these are mostly simulation tools which are required in the design and engineering phase. And our Indian engineers need to be aware of these software tools and how to use them in applications in real life scenarios. At an electric vehicle system level, as we all know, energy efficiency is very critical for electric vehicles, and hence our engineers need to have a strong understanding of how component sizing can be done to improve energy efficiency, how to model and simulate a combination of EV component systems to improve energy efficiency, and also how to design a number of software functions, whether it is for the battery management systems, inverters, or for the DC-DC converters, and many more. And here again, they would require a strong knowledge of the software simulation tools which are listed under. Coming to autonomous vehicles, all of us are aware for an autonomous vehicle to function, It needs to have a comprehensive understanding of the environment around it. For that, it is fitted with a lot of sensors. All the data coming from sensors needs to be analyzed in order to figure out the path plan. So the skills that are listed to the right, a lot of computer vision skills, a lot of LiDAR and radar processing skills, functional safety, trajectory planning and optimization, and a number of other skills. Here, the list of tools that are listed below are slightly different from what we've discussed so far. It requires significant computer programming skills in this area of autonomous vehicles. Coming to connected vehicles, here it is the new age computer science skills, whether it is 5G, whether it is V2X, a lot of data analytics, knowledge of digital twin, cyber security, and cloud computing. These are very, very critical in order to ensure that the connected vehicle that they work on. These skills are very critical to ensure that they can work on connected vehicles. Now, we've quickly gone through what are the skill sets that are required at a very high level for engineering components, for designing electric vehicles, also for designing autonomous and connected vehicles. But how can these be imparted? Who needs to learn these skills and how can these be imparted at scale? There are three building blocks again we have put over here. Number one is industry relevant content. I cannot emphasize more on this part. The reason being, this being relatively a newer industry compared to the regular automotive vehicles, right? It requires that these people be skilled with the content developed by industry experts, and it's very industry relevant content. Number two, we've already spoken enough about the simulation tools and methods, and having experiential learning either for students or for employees will be the icing on the cake to improve the learning outcomes. Now, coming to who should be taught all of these skills. Number one, given the rate of the pace at which the EV industry is evolving, we require significant amount of talent across all levels. Like for any other industry, it's a pyramid of skills that we require. We require a significant number of skills at the bottom of the pyramid, that is at the entry level. Engineering students or fresh graduates, they are in academia, they might not have access to industry relevant content. They might not have access to the faculty who can teach them about electric vehicles, autonomous vehicles, or connected vehicles. And hence, there is a requirement for platforms like us to facilitate this along with the industry, an employability enhancement program, where students in the third and final year or after graduating get to learn from industry experts, get to work on very industry relevant projects, almost to mimic the environment that they would face in the industry even before they come there. For the experienced professionals who are already working in corporates, they might have a day job to do, but they need to be upskilled or reskilled in order to work on EV and autonomous vehicles. For this, they need an enterprise learning management system which can offer them asynchronous and personalized learning. They also need one-to-one learning, one-to-one coaching, mentor coaching in order to develop deep functional and domain expertise. We at SKILL-LYNC are enabling this for students with the help of academia and for corporates and for experienced people with the help of corporates. Now, I would like to talk more about how we are enabling this and how the industry can benefit from this. So, as I said, we are very actively working with the corporates and academia to create a talent pool for powering the EV revolution. There are three kinds of services that we provide. We provide employability enhancement programs for students and fresh graduates, and we provide upskilling and reskilling for people working in the corporates. As you can see, as I've told you before, we've raised about $20 million and have invested most of this money in building our content. We have about 250 plus courses available on our platform. We are present across 6 cities with 1,200 plus employees. We are present across Hyderabad, Chennai, Bangalore, Bombay, Pune, and Delhi. At any point of time, we have about 10,000 plus engineering students and freshers taking up our programs on our platform. There are 1,000 plus working professionals who are actually paying out of their pocket to learn these new age skills. There are 100 plus companies which leverage our platform either for recruiting trained talent or using our platform as an extended learning management system to upskill their employees. Getting into a bit of detail, and given that the topic is about creating a talent ecosystem, our e-learning platform has enabled people from multiple parts of India and multiple parts of the world to have access to this industry relevant content. So we have 80% of the learners on our platform come from India. They come from, as you can see, they come from all parts of India, right? And the reason why they take up these coursework is they want to work in EV and autonomous, but they don't have the resources either in their colleges or or some of them even in the corporates. And surprisingly, a number of students from US and Europe have taken up our coursework in electric vehicles, and most of them are master's students who are pursuing their programs in automotive design or electric vehicle design, etc. Coming to specifically in India, about 60% of these people are students or freshers, and they come from all tiers of colleges, whether it is tier ones like IITs, NITs, and triple ITs, or tier twos and tier threes as well. We strongly believe that irrespective of the tier of college they come from, if they actually learn this industry grade content with the help of experts, they can be a great source of talent for the EV and autonomous industry. As for the experienced folks, there are a lot of experienced folk, as you can see, a number of them from automotive companies who are subscribing out of their own interest, paying out of their own pockets in order to subscribe to our learning management system. What do all these people learn? We offer a variety of programs, right? As we said, the electric vehicle program is one of our popular program, electric vehicle and autonomous vehicle program, where we talk about the powertrain architecture, battery technologies, power electronics, ADAS, automotive embedded systems, and AutoSAR. There's a huge requirement for embedded engineers, so we have a program on embedded systems. Given the recent chip shortage and Indian government push to develop chips within India itself, we've introduced a VLSI design course. We also have a course dedicated to 5G. Similarly, we have courses for mechanical engineers who want to get into hybrid electric vehicle design, and also on basic engineering design, CFD and FEA coursework. We also have coursework in the new age domains such as autonomous vehicles, automotive cybersecurity, data analytics and data science, full stack web development. Some of these skills are very critical in the autonomous and connected vehicle space, like we talked about in the first half of my presentation. What do all these learners do? They consume about 400 to 500 hours of learning. So this is not short-term learning. This is very intense learning. They have access to industry relevant video content, which is been recorded with 1250 plus industry experts. So 1/3 of the time they spend actually watching these recorded lectures. And then they have access to 150 plus full-time faculty. We have full-time faculty who are people from ex-Bosch, ex-MathWorks, ex-Samsung, or people who worked in Renault Nissan before, KPIT before. So these are people who worked in the industry and now who've joined us in order to teach. So these are full-time faculty that we have. Similarly, given that application-oriented learning is extremely critical, we ensure that they spend 1/3 of their time doing industry-grade project work. As I told you, both in electric vehicles and autonomous vehicles, the hands-on industry relevant projects are very critical in order to ensure that this talent pool is actually relevant and useful for the industry. So they work on simulating battery management systems, the mechanical design of lithium-ion battery packs, modeling of an entire electric vehicle using an induction motor, etc. Implementing parking management systems or traffic assist features, a lot of ADAS features on the autonomous vehicle side as well. We are also setting up experience centers across cities to ensure that learners have access to hands-on learning. They actually can see how the software they develop or the systems that they develop are working in the real life world. I think the validation of our platform, of our method of teaching is right now a number of corporates, whether it is Renault Nissan Technology and Business Center in India, the Chennai people who have 8,000 employees, or Yazaki, or service providers such as Cyient and Tata Elxsi. They have taken access to our enterprise learning management system, specifically in topics related to EV and autonomous vehicles. We are in multiple conversations with a number of OEMs and service players, again, in the automotive design, electric vehicles, embedded systems play. This is what we had to share about how SKILL-LYNC is enabling and creating a talent ecosystem for electric vehicles and autonomous vehicles. If you're interested, please feel free to contact us. We're leaving one of our industry program manager contact details here on the screen. Once again, I would like to thank the ET team for having SKILL-LYNC on this forum. Thank you.
Thank you, Mr. Bandaru, for updating us on how SKILL-LYNC is creating a talent ecosystem for EV industry. Now we'll move on to the next session. Stay tuned, everyone, and keep tweeting using the hashtag ETAutoEVC.